So Biot-Savart law formula is dB is equal to mu 0 by 4 pi IDL cross R divided by R cube into sin cube sin theta. Okay, so we are writing IDL divided by R square into sin theta. Okay, this is the formula for dB. That this is the formula for Biot-Savart law. After that, Biot-Savart law, he says for a coil, for a circular coil. Okay, current carrying circular coil. So what is the formula? Can you tell me? B is equal to mu 0 I by 2R. Just you have to learn this formula. In Biot-Savart law, he tells about only the circular coil. Okay. Next one is Ampere circuital law. What is the formula for Ampere circuital law?
Sir, integration of B dot dl.
Very good. B dot dl is equal to what? Mu 0 into I, capital I. Okay. B is equal to mu 0 into B dot L is equal to mu 0 into capital I. Now, in that he tells about the wire first. Okay. A straight wire. Straight wire. So what is the formula there? B is equal to what? Mu 0 I by 2 pi R. Okay. So mu 0 I by 2 pi R. That's the formula. Okay. Why? Because this is the current. Here this is the coil. This is the coil and we want to find out the magnetic field at the center. R is the radius. I is the current flowing through this one. Okay. I is the current flowing through this one. So R is the radius. So the formula is here. B is the magnetic field. The magnetic field is like this. Okay, when the current is flowing, this is the magnetic field. B is the magnetic field. Here, if there is this is the current I, then this is the this is said to be Amperian loop. Okay, Amperian loop. So this diagram is not in this book. This diagram is in this figure was very important, which is not there in the textbook. It is there in H.C. Verma. Okay, so this is a magnetic field, this is Amperian loop. Okay, so for straight wire, this is the formula. Next one is solenoid. There are three cases here: straight wire, solenoid, and toroid. The formula for solenoid is what? B is equal to, this is the solenoid. B is equal to mu 0 Ni. Okay, what is N here? What is small n?
Number of loops.
Number of turns per unit length. Number density. Number of turns per unit length. So we have formula here. Small n is equal to number of turns per unit length. Okay, this is the formula. Next is what? Next we have. Next is toroid. Okay, toroid is like a donut. Okay, keep that in the mind. It's like a donut. So it's like this. Okay, current goes in from one end and comes out from the other end. As I told you yesterday, the magnet here, there are 3 points, P, Q, and R. R is at the center. So magnetic field here is 0. Magnetic field is here 0. Why? What is the reason behind it?
Sir, because the two of them will cancel out each other.
Very good, very good. So what is happening, here when suppose if the wire goes in, so it will become cross. When the wire comes out from here, it becomes dot, whatever it is. It depends, because if the wire goes in like this, okay, no problem. That means the wire is going in this way.
Like this.
Okay, suppose if the wire goes like this, it comes out the other way. It comes out in this way.
Okay.
So it like maybe the folding is in a different way.
Okay.
Yesterday, which I told.
But it won't affect.
Yeah, no, that won't affect, because it is anyways cancelling out. No.
Okay.
Understood. So here, see here, it is like this. No, see. So wire is going in. In means cross. Coming out means dot. So there is a magnetic field around it. If it is cross, how is the magnetic field? Anti-clockwise or clockwise? If the wire is coming out, how will be the magnetic field? It will
Clockwise.
be. See, wire is coming out. Look at my
So wire
finger.
coming out will be
Anti-clockwise.
anti-clockwise.
And anti-clock, ACW. Okay. And wire is going in. It will be
Clockwise.
clockwise. Very good. If I'm telling you, if you are able to do this one, you will get at least 4 to 5 mark. This concept, what I'm telling you, easily you will get, because definitely there are at least 1 or 2 questions from this one. Okay.
So,
Now,
sir, from which of the chapters has the most numericals? Like,
see, it is
which
nothing.
will
We
have-
cannot say like that, because every question has ABCs, like parts they are giving.
Yes, sir.
Like suppose if A he is asking a reason, B he is a numerical.
Okay, sir.
So you cannot say exactly like there will be numerical like that. But the problem with this type of papers, I'm telling you, really it is a like mind what I say, crazy papers. Crazy paper means It takes so much time to understand the paper. Some question will be very tricky and which will spoil your mood. Understood?
Yes, sir.
So now the main important, once I am done with this one, I'll be solving with you the past papers.
Okay, sir.
I'm not going to give any homework to you. You have to be in my class and you have to solve the question paper with me. Then I will
Okay,
tell you
sir.
the tricks how to remember. Got
Okay,
it?
sir.
Unless and until you do at least 4 to 5 past words with me, you cannot do anything in the answer in the exam. So
Yes,
we
sir.
will
So this
do,
exam or for the
for this
boards?
also it is going to be with the same sample paper. Means
Okay, sir.
pattern will be same. 18
Okay, sir.
questions. 18 questions will be there in you know 18 questions, like sorry, 18 for MCQs will be there. Okay, and MCQs will be there. After that, 2 marker, 3 marker, 5 marker, and case studies. 2 case studies are there.
Yes, sir.
That is how the paper is going to go. Okay, so we have so when the magnetic field is going in, it is the cross. When the wire is coming out, it is dot. The magnetic field here is anti-clockwise. The magnetic field here is anti-clockwise. So what happens at this point, if I want to find out the magnetic field, the clockwise and anti-clockwise magnetic field will cancel out each other. So the magnetic field here inside will be 0, and the magnetic field here also it will be 0, because they are cancelling out each other. But the magnetic field here will not be 0. Why? Because they both are contributing to the magnetic field inside that. So the magnetic field here is what? The formula is B dot L equal to mu 0 and I. Okay. But what is the length? Length of the loop? Length is what? We have number of turns. Number of turns, N is equal to number of turns per unit length. So capital N is equal to small n into L. But what is L? L is equal to 2 pi r. Okay. L equal to 2 pi r. Length of the that is perimeter of the circle. Perimeter of the circle is L is equal to 2 pi r. So we are going to substitute. We are going to substitute here. L is equal to what here? N is equal to B into L is equal to mu 0 into 2 pi r into I. But again, what is L here? L is again 2 pi r. So here also I'll write here 2 pi r. So this 2 pi r will go away. Again, you are left with mu 0 is mu 0 ni. Okay, mu 0 ni. This is the formula. So the formula for solenoid and toroid is same, but while solving the numerical, you should be little careful. Clear? Yeah. Yeah, 2 pi here also. No? 2 pi r I wrote. 2 pi r, 2 pi r. Mu 0 ni. Same. But small n, not capital N.
Yeah, okay.
This is small n. Okay, mu 0 ni.
Okay.
Okay, not capital N. Keep that in the mind. Keep this in the mind. Capital N is number of turns only. Number of turns. And small n is number of turns per unit length. How many turns are there in 1 centimeter or 1 millimeter? That tells about the number density. Okay. Now, so that completes your all the 4 cases: circular coil, straight wire, solenoid, and toroid. All the 4 concepts we have done. Now, next one is force between 2 parallel conductors and ampere. Okay, this is again one more derivation. Okay, I'll do on a separate page. Do you have any doubts in this one, in this concept?
They'll ask this derivation.
This much only toroid derivation.
They'll ask it?
Yeah, they asked in one of the boards.
How much marks? 2 marks?
3 marks.
This is 3 marks.
This for 3 marks. You have to draw the diagram. 2 diagrams are there. One you have to draw just like this, and the second one is you have to draw this cross and dots
So
overall like this.
this one, however we draw it.
See, I will just show you how to draw the diagram. Okay, so how it is here, the wire goes, first diagram will be like this. Okay, first diagram you may not draw much, just draw this wire goes in like this. This is the wire, current goes in and the current comes out. This is the first diagram. The second diagram is we can write here P and Q like that. We can write P, Q, and R like this, or we can write magnetic field. Here is B1, here it is B2, and here is B3 like that. Magnetic. We can draw. This is the first diagram. The second, like make it a little closer. Don't keep it like away from each other. Okay, very close. When you're drawing, you have to draw it very close like this. See, like this you have to draw. Okay, don't draw much like this. You have to draw. The next one is what happens when the wire goes in, all the cross will be there here. If the wire is going in, all the cross will be there like this, because the wire is going in. So magnetic field will be anti-clockwise. Okay, going in means clockwise, sorry, coming out anti-clockwise. So here all the dots we have to keep like this, means the wire is coming out. Okay, and the magnetic field, like dotted line with the magnetic field when you're drawing. Here also there is one more dotted line which for the magnetic field. Here also there is one more dotted line for the magnetic field. Three dotted lines are there. One is B1, magnetic field B1, this is B2, and this is B3. So this magnetic field has an arrow also. Okay, magnetic field B. Is that clear? There are three magnetic fields.
Yes, sir.
One inside.
The outer magnetic.
I did
field
in the
is
other
this
way.
one.
Here, this dotted line.
Yeah, that is for this one. So when it curls.
When it's go,
that's
this is
not-
outside of the
Toroid.
toroid, inside of the toroid, in between the toroid.
This one.
Yeah, this one. This dotted line is inside the toroid. So we have to show this diagram, and you have to draw the radius also. But small r1 is the radius. Here r2, here r3. Okay, there are three radius. You can write b1, b2, b3, r1, r2, r3, same way. Or you can write b1, b2, and b3 like this, and you can write r1, r2, and r3. Only the magnetic field is due to r2, not due to b2 and r2. Okay, these two diagrams you have to draw. Half mark for each. It is like that, and the derivation carries mark. And you have to draw this to show the magnetic field also. Clear?
Yes, sir.
So
So how much will the diagram be if there are like
half
two
mark for
diagrams?
each diagram.
Half
Labeling.
mark for each. Okay, sir.
You have to keep that in the mind. Whatever the diagram, whether it is in figures, whether it is in physics or chemistry or biology, draw with the pencil and label it properly. Then only you will get marks. Okay.
Okay, sir.
Okay. Chalo. Any more doubts here? Yeah.
No, sir.
This one, right?
So the toroid is the toroid derivation, right?
Yeah. Derivation. Yeah. What can you say it again?
So the toroid, that is the derivation for it.
Yeah,
with the
that's
formula.
it. That's it. But you have to write here. Magnetic field B1 is 0, B2 is 0. Why it is 0? You have to write the reason here. Why? Because the magnetic field due to the wire going in and wire coming out is clockwise and anti-clockwise respectively. Because of that, they cancel out each other. So similarly, B2 also will be 0. Like that, you have to write. Sorry, B3 will be 0. B1 is inside, B2 is in here. B1 is here, inner region. B2 is inside the toroid. B3 is outer region. Like that. Sorry.
Okay, sir.
Okay, like that you have to write. Is that clear?
So this question will take you values.
Yeah, no. This is first derivation. After that, they will give values also.
50 volts. and
Like
some
I1,
other-
I2, two currents. Like
You asked one question. I don't know.
yeah. That is very simple one. Yeah.
Can you-
I'll do that. I'll do that.
You have those questions that you asked me?
Yeah, it is there with me. I'll just give that also.
You correct.
All got outstanding marks.
Thank you, sir.
So this was a question. One of the question I kept a test in the class. Okay. So our heroes got very nice marks. Okay. So this was moving charge and this is the current electricity chapter. Okay. So anyways, I'll solve this paper with you people. So okay, right hand thumb rule and right hand rule. There's only one rule, man. Right hand rule. Right hand thumb rule only. There is no right hand rule. Okay. Right hand.
So because
rule
in
is
your
that- see,
Yes, sir.
we can conclude two things from right hand rule. One is if this carries the current, this will tell the direction of the magnetic field. If this carries the current, this will tell the direction of the magnetic field. This is
Yes,
first
sir.
rule, right hand thumb rule. Now, if this carries the current, the curled fingers carries the current, then this will tell the north pole. And this will be the
Okay,
south
sir.
pole. Once again, if this carries the thumb indicates the direction of the current, curled finger shows the direction of the magnetic field. Now, and one more thing, if the curled finger shows the direction of the current, thumb will tell the north pole and this will tell the south pole. Clear?
Yes, sir.
Is that clear? Okay.
There is one right hand palm rule also, right?
No.
That is-
This is right hand. This is left. No. Right hand palm rule must for the same rule only. They say like that. Like they say like that. Do like this and try to do that. This is right hand thumb rule only basically.
So right hand thumb rule and that right hand rule are the same thing, right?
Right hand rule that's what we can conclude. Two things I'm saying. One is if
Yes, sir.
the current, this is magnetic field.
Yes, sir.
And if this is current, these three terms are current, this is north pole. Got it?
Okay, sir.
Now
Yes, sir.
come to this one, right? Left hand principle. This is left hand, Fleming left hand principle. If this is I'll come to the right hand also. Fleming left hand principle, this is the magnetic field. This is the magnetic field. This is current. This is the resultant force. This is magnetic field. This is current. This is magnetic. This is the resultant force. Come to right hand. In right hand, if this is the magnetic field, this is the motion of the conductor. magnetic field, motion of the conductor. This is induced current. Is that clear?
Okay, sir.
Once again,
Yes,
this
sir.
is magnetic field. This is motion of the conductor. This is induced current. Got it? Is that clear, all
Yes,
of you?
sir.
Yes, madam. Is it clear?
Yes, sir.
Okay, chalo. So I'm going ahead with the next derivation. Then we'll do some numericals also on that. Okay. So on toroid also we'll do a numerical. We'll do a numerical on toroid and solenoid, then a normal wire and like that. Okay. All four problems.
Fifth question was-
What is the fifth one? That I will do after this. This is a derivation. No? Yeah, I'll do that.
And then what is which derivation is the seventh question?
It's not derivation. I wrote just try write the for the same formula only.
Or the fifth one, the seventh question.
Yeah.
derivation.
No, not derivation. It's only formula. 1 mark. See, write the expression of the force experienced.
So this one, no, that is.
Same only formula writing. Only this formula we have to write. That's it. For that I give 1 mark. No one wrote. Okay. So we'll go ahead. Chalo, we'll go ahead with the next derivation. He says force on a force between two parallel currents, an ampere. Okay. So force between two parallel currents and the ampere. Force between two parallel currents and ampere. Now suppose we have two wires like this. Two wires carrying current. This one first wire is A, second wire is B. So the current in first wire is IA, current in the second wire is IB. And the distance between the two wires is D. This is very, very important. Especially in India, we have overhead wiring. In India, it is overhead wiring. Here in UAE, we don't have overhead wiring. Overhead wires are not there. Only in Ajman or some places, in rural places, you will see the overhead cables. Okay. But otherwise, all the cables are buried in the ground. Now, these wires, because this burying is expensive, because we have to dig it and then again put the pipes, and again in that we have to put that cable. Those cables are very expensive. It has double casing, triple casing like that, so that the rats inside the in the ground should not bite the wires for that reason. So there are so many safety precautions for that. But anyways, in India we have like overhead cables. In overhead cables, this current, there are like mostly, like if you look at the pole, like this will be the wires. Maybe you might have seen on the overhead cable, like wires will be there like this. Have you seen like overhead cables like this? One like cables will be there like this. Yes.
Yes, sir.
Now D is the distance between the two wires, and we are taking